Okay, so whether you're a GCSE or A-level student, I'm hoping that by the end of watching this, you should understand what is meant by the mole in chemistry, be able to use the relationship between number of moles, mass, and molar mass, and then hopefully you could use this idea of moles, this mole concept, to work out reacting masses in equations. So, firstly then, considering a simple reaction, oxygen reacting with hydrogen to form water. If, in a particular scenario, we take 32 grams of oxygen, you'll find that to completely react with all that oxygen, you're going to need 4 grams of hydrogen. Okay, so you could find that by experiment. And you know that mass is conserved in reactions, so the mass of the reactants equals the mass of the products, because the atoms don't disappear. We've got the same number and type of atoms on the left-hand side of the equation as on the right-hand side of the equation. So in theory, our products, our water, should weigh 36 grams. Now, the interesting thing is that the oxygen and the hydrogen will always react in this ratio. So if we were to halve the quantity of the reactants, so if we were to go for 16 grams of oxygen, we only need to react that with 2 grams of hydrogen, and we form half the mass of water, we form 18 grams. If we were to double from 32 to 64 grams of oxygen, we'd need double the mass of hydrogen, we need 8 grams, and we get double the mass of water. If we were to go for an eighth of the mass of oxygen, then we'd only need 0.5 grams of hydrogen, and we'd only form 4.5 grams of water. And we could continue like this, working out different quantities, as long as we knew all the quantities in the first place, so 32 grams of oxygen, 4 grams of hydrogen, 36 grams of water. But what if I posed something like this? Said, what if we've got 20 grams of oxygen, how many grams of hydrogen, how many grams of water are we going to form? Now, we can't look at the equation and answer this straight away, because the equation doesn't tell us that 1 gram of oxygen reacts with 2 grams of hydrogen to form 2 grams of water. That's not what these numbers mean, and we know it can't be that case, because then you'd have 3 grams of reactants and 2 grams of products, and that's not conserving mass. What the equation is actually telling us is that 1 molecule of oxygen reacts with 2 molecules of hydrogen to form 2 molecules of water. So actually, we need some way of linking the mass that we usually measure substances in to the number of particles, because substances react by number of particles, not by mass. Now, the mole is a quantity that links the number of particles with mass, and it's going to allow us to work this sort of thing out, to work out, say, the mass of water produced from reacting 20 grams of oxygen with the right amount of hydrogen. Now, the mole then is defined as the amount of substance that contains as many particles as there are atoms in 12 grams of carbon-12. Now, that's not a very friendly definition, so if we just think of what that actually means, if you were to weigh out 12 grams of carbon, you would find, if you counted that, and counted the atoms inside it, that there are 6 times 10 to the 23, or 6 with 23 zeros after it, that many atoms or that many particles of carbon within those 12 grams of carbon. That number, that 6 times 10 to the 23, we call 1 mole. It's just a number. Just like a dozen is a number and it means 12. A mole means 6 times 10 to the 23. Now, we're using carbon-12 here because carbon-12 is used to define relative atomic mass, so don't worry about that. The important thing is why we're using 12 grams of carbon-12. If we use 12 grams of carbon-12, chemists are quite clever about this, and they wanted to make everything simple. It means that the molar mass of a substance, i.e. the mass of 1 mole of that substance, is equal to its relative atomic mass, or relative formula mass if it's a compound. So this is really useful. So for carbon, carbon's relative atomic mass is 12. That means that 1 mole of carbon, this 6 times 10 to the 23 particles of carbon, weighs 12 grams. Consider the same for oxygen. Oxygen's relative atomic mass is 16. That means that its molar mass, the mass of 1 mole of oxygen, is 16. So 1 mole of oxygen weighs 16 grams. I should say 1 mole of oxygen atoms at this stage weighs 16 grams. So, in summary, the mole is the unit for the amount of substance. 1 mole of something contains 6 times 10 to the 23 particles of that substance. You could get a bit silly here. You could say, for instance, 1 mole of bananas is 6 times 10 to the 23 bananas. But of course we're dealing just with atoms and molecules here. The mass in grams then of 1 mole of a substance is known as its molar mass. This is numerically the same as the relative atomic mass. So when you look at a periodic table, you really need to be thinking now of this number here, not as the relative atomic mass, it still is obviously, but for these calculations, consider it as the molar mass, i.e. 1 mole of a substance is going to weigh that much there in grams. And 1 mole of oxygen atoms will weigh 16 grams. So in a bit more detail, let's just have a think about this. If we've got 1 mole of carbon atoms, that is 6 times 10 to the 23 atoms of carbon. You look on the periodic table, see that it's got a relative atomic mass of 12, so its molar mass is also 12. 1 mole of carbon will weigh 12 grams. Now oxygen atoms are a little bit heavier. 1 mole of oxygen atoms weighs 16 grams. But oxygen doesn't go around as single atoms, it goes around as pairs, so it goes around as O2 molecules. 1 mole of O2 molecules is 6 times 10 to the 23 molecules. But in this case, the molar mass, how heavy 1 mole is, it's got 2 oxygen atoms in, so it's 2 times 16 is 32 grams per mole. Similarly, if we take a compound, carbon dioxide's got 1 carbon in it and 2 oxygens. Again, 1 mole of carbon dioxide molecules is 6 times 10 to the 23 molecules. But its molar mass is 12 for the carbon, plus 2 lots of 16 for the 2 oxygens, comes to 44 grams per mole. That 1 mole of carbon dioxide molecules, or 6 times 10 to the 23 carbon dioxide molecules, would weigh 44 grams. Okay, let's see if you're with me then. If I were to give you 24 grams of carbon, given that 1 mole of carbon weighs 12 grams, how many moles of carbon is that? Well, 24 divided by 12 is 2. You'd have 2 moles of carbon because each mole weighs 12 grams, and I've given you 24 grams. So we can define an equation. We can say the number of moles of a substance is its mass in grams divided by its molar mass. And if you like, you can either rearrange that equation if you wanted to find the other quantities, or you can express it in a triangle like this. The triangles work by, if you want to find out the number of moles of something, you cover up moles and you say, right, okay, the number of moles is mass divided by molar mass. If we want to find the mass of a substance, we know how many moles we've got and how heavy it is, what its molar mass is. We take the number of moles and we times by molar mass. If we want to find the molar mass of a substance, and we know we've got a certain number of moles of it and it weighs a certain amount in grams, we take the mass in grams and divide by the number of moles. So here's some practice. What I suggest you do is, I've given you the relative atomic masses up here. Remember, they're the same as the molar masses. Probably pause the video now, have a go at these, and then I'll take you through the answers. So, how many moles of carbon are there in 36 grams of carbon? Well, we've been given the mass, that's 36 grams. The molar mass is 12. 36 divided by 12 gives you 3 moles. How many moles of carbon dioxide are there in 88 grams of carbon dioxide? Well, the mass is 88. The molar mass of carbon dioxide is 44, we've seen that before. To remind you again, it's got 1 carbon, 2 oxygens, 12 plus 2 lots of 16, which is 32. 12 plus 32 is 44. 88 divided by 44, 2 moles. The mass in grams of 2 moles of magnesium, well, magnesium weighs 24 grams per mole. 2 moles of it, 2 times 24, 48 moles. Sorry, that should say 48 grams. So 48 grams of magnesium. What is the molar mass of an element if 4 moles of it weigh 28 grams? And then what is the element? Well, if 4 moles of it weigh 28 grams, the mass is 28 grams, the number of moles is 4, 28 divided by 4 gives us a molar mass of 7 grams per mole. Look that up on the periodic table. An element with 7 grams per mole is lithium. Okay, we're nearly ready to bring this all together now into a reacting mass calculation, but we need to just remind ourselves what these ratios in equations really mean. So if we look at nitrogen plus hydrogen forming ammonia, balance symbol equation for that here shows us 1 molecule of nitrogen reacts with 3 molecules of hydrogen to form 2 molecules of ammonia. If we had 2 molecules of nitrogen, they would react with 6 molecules of hydrogen to give us 2 molecules of ammonia. Similarly, we can do the same with moles. So instead of saying 1 molecule of nitrogen reacts with 3 molecules of hydrogen to give us 2 molecules of ammonia, we can say 1 mole of nitrogen reacts with 3 moles of hydrogen to give us 2 moles of ammonia. So how many moles of ammonia are produced from 1 mole of nitrogen? Is 2. How many moles of ammonia are formed from 2 moles of nitrogen? So if 1 mole gives 2 moles of ammonia, so 1 mole of nitrogen gives 2 moles of ammonia, 2 moles of nitrogen would give 4 moles of ammonia. How many moles of ammonia are formed from 10 moles of nitrogen? Well, if 1 gives 2, 10 will give 20. How many moles of ammonia are formed from 6 moles of hydrogen? Well, 3 moles of hydrogen give 2 moles of ammonia. So if we double that to 6 moles of hydrogen, we'll double the ammonia to 4 moles. And then how many moles of hydrogen would be required to form 5 moles of ammonia? Well, to go from 2 to 5, we times by 2.5. So 3 times by 2.5, 7.5. Right, here we go then, putting it all together. Imagine a question like this then. What mass of carbon dioxide is formed from the thermal decomposition of 300 grams of calcium carbonate? Before we start, we've got to have a balanced equation. So step 1, write a balanced equation. Calcium carbonate decomposes to calcium oxide and carbon dioxide. Right, let's write what we've actually got and what we want to find out. We know we got 300 grams of calcium carbonate, and we want to find out the mass of carbon dioxide. We know the equation does not tell us that 1 gram of calcium carbonate gives us 1 gram of calcium oxide and 1 gram of carbon dioxide. It tells us 1 mole of calcium carbonate gives us 1 mole of calcium oxide and 1 mole of carbon dioxide. So we've got to be working in moles. So, calculate the number of moles of calcium carbonate. We should know by now then that's the mass of calcium carbonate divided by its molar mass. Calcium is 40 grams per mole, carbon 12 grams per mole, 3 lots of oxygen at 12 grams per mole each. Its molar mass is 100. So its mass, 300 grams, divided by molar mass of 100, gives us 3 moles of calcium carbonate. Then look at the balanced equation again. 1 mole of calcium carbonate will produce 1 mole of carbon dioxide. Now we physically have 3 moles here in this scenario. Our 300 grams is 3 moles. So if 1 mole of calcium carbonate gives 1 mole of carbon dioxide, 3 moles of calcium carbonate gives 3 moles of carbon dioxide. So we're nearly there. We wanted the mass of carbon dioxide. We've got the number of moles at the moment. We now know that the mass of something is equal to the number of moles times by its molar mass. So the mass of carbon dioxide is equal to the number of moles of carbon dioxide, which we calculated, it's 3, times by the molar mass. So 3 times by 44, which you might remember from before. Carbon dioxide, carbon at 12, 2 lots of oxygen at 16 each. 132 grams of carbon dioxide are formed from 300 grams of calcium carbonate. Here's a general strategy then. So any moles question can be answered using this 4-step strategy. Got to have a balanced simple equation. It's the first step. You then use the mass given in the question. So in our case here, it was 300 grams of calcium carbonate. To calculate the amount in moles of that substance. So we calculated the number of moles of calcium carbonate. Then use this amount and the equation to work out the amount in moles of a different substance. So step 3, we knew that 1 mole of calcium carbonate gave 1 mole of carbon dioxide. So we know 3 moles calcium carbonate gives 3 moles of carbon dioxide. And then use that amount that you've just obtained from step 3 to calculate the mass of the substance. We knew we had 3 moles times by its molar mass. We worked out the mass of carbon dioxide. Okay, here's one for you to have a go at. I'll display the answer in a second, so you might want to pause the video. My one tip for this is to see here that 4 moles of lithium nitrate produce 1 mole of oxygen. Okay, good luck. Answer coming up in a sec. So you should have got that. Hope you did.